In this concept, we're going to talk about the perimeter and area of similar figures. Now, we talked about similarity before, right? So, if the scale factor of two similar figures is a over b, then we can say that the ratio of the perimeters is also a over b, and the ratio of the areas is a squared over b squared, right? Areas are squared. Let's look at an example of how we can apply this. So the two rectangles shown above are similar. Okay. The perimeter of the larger rectangle is 20 inches. So this one has a perimeter of 20 inches. What is the perimeter of the smaller rectangle? So to find the perimeter of the small rectangle, again, we need to get the scale factor, which can essentially be found by taking a ratio between any two similar sides, right? Which we can do, right? We have this side 6 and this side is 2. So 6 over 2 is 3 over 1, which is 3. So this is the scale factor, meaning this triangle is 3 times as large as this triangle. Okay, in terms of perimeter. In terms of area, it is 3 times squared as big as it is 3 squared times as big as the other one. Okay, so be careful. Area always gets a square. So the ratio of the perimeters of the two similar figures is the same as the scale factor of the similar figures. So the ratio of perimeters is 3 over 1 as well. So set up a proportion to find the perimeter. It is given that the perimeter of the larger rectangle is 20 inches. So if you got the scale factor by dividing the larger figure by the smaller figure, then when you set up the proportion, put the value for the larger figure on top, whether it's the perimeter or area, etc. Okay, so the scale factor is 3 over 1, and then we have our ratio of perimeters, 20 over x. Okay, and then we just solve for x, which is the perimeter of the smaller triangle. Cross multiply, so 3x equals 20, so x equals 20 over 3, which is about 6 and change, 6.66, something like that. Okay. Here's another example. We have two trapezoids, and they are similar. If the area of the smaller trapezoid is 20 square units, so this guy, what is the area of the larger trapezoid? So again, we can determine the scale factor by dividing this side by this side, right? Similar sides, or corresponding sides, we should say, of the similar figures. So 10 divided by 4, which is 5 over 2, which is something like 2.5, right? The ratio of the areas of two similar figures is the square of the scale factor. So it is 2.5 squared, right? So the scale factor for areas is 2.5 squared. Find the square of the scale factor, which, like we said, 2.5 squared, or, whatever, 5 squared over 2 squared, which is 25 over 4. We can set up a proportion to find the area. So again, this is 2.5 squared. Which is essentially, so 25 divided by 4, what is that? So that's 6.25, right? So 6.25 is equal to x over 20, and then just cross multiply. So x equals, we could say 6.25 times 20, right? Which is also this. So either way is fine, depending on how your brain is organized. Okay, and here we have our exercises. Please pause the video, work on these, and come back for the solutions. Okay, the triangles in the figure below are similar triangles. If the perimeter of the smaller triangle is 36 units, find the perimeter of the larger triangle. So again, our scale factor is 12 over 8. Again, take any two corresponding sides, right? Take the ratio, larger to smaller. So 12 over 8 is what? Divided by 4 is 2, divided by 4 is 3. So 3/2. So that 3/2 set up a proportion is equal to for perimeter, the scale factor does not get squared. Okay, the scale factor is what it is. So it's 3 over 2, it's just 3 over 2. So 3 over 2 is equal to x, which is the perimeter of the larger triangle, which we need to find, right, divided by 36 units. And then we can just multiply by 36 on both sides, right, to get rid of this and isolate the x. So x is equal to 36 times 3/2, which is equal to 54 units. Okay. This is the perimeter of the larger triangle. Next exercise. The figure below contains two similar rectangles. If the area of the larger rectangle is 65 square units, find the area of the smaller rectangle. So again, very quickly, we can find the scale factor, and that is going to be 3. Okay. But since it's squared, when we set it up for area, let's just say 3 over 1. When we set it up for area, we're going to have 3 over 1 squared, right? Which is just 9 squared, which is equal to the area of the larger rectangle, 65, over the area of the smaller rectangle, x. Okay, sorry, this is just 9. So times x, and then divided by 9, and then divided by 9, right, to bring the 9 on the other side. So x's cancel, 9's cancel, so we'll get x equals 65 over 9. Okay, so 65 divided by 9 is just 7.22 square units. Okay, this is the area of the smaller rectangle in comparison to the larger rectangle. All right, and this is it for this concept. See you in the next video.